Okay, number 6. First thing, we've got this function. Don't get thrown off by the x and the t. It's the same as if you had y and x. It's just different letters. They went t for seconds, and I don't know why they picked x here. They just felt like it. First thing it says is find the value of t when the cyclist reaches the top. Important to note is in the problem, they actually tell you that the hill is 200 meters long. And so in that case, you're just looking for when the function says 200 equals 3t plus the natural log of 2t plus 1. Now, if this was a simpler function, I'd say go ahead and solve it. It's not, so use your calculator. Here's what that graph looks like, and as you can see, it is at 200 at about 65 seconds. The other thing is that if you look at this purple graph, which is our function, there is no maximum. This guy's just going to shoot off. So this biker is kind of starting slow and then just kind of chugs regularly at the steady pace all the way up. We're basically a steady pace all the way up. So here's our answer for that first bit, which is 60, so a little bit after 65 seconds. So it's about 65 seconds to reach the top. Okay, cool. When they're asking for expression for velocity, it's just asking for the derivative of this. So we're just gonna get the derivative. We've got x is equal to 3t plus the natural log of 2t plus 1. This derivative would just be 3 plus, this bit is going to require the chain rule, so I'm going to write y equals the natural log of u. U is 2t plus 1. dy du, sorry, that's a u, is 1 over u. du dt is 2, so we're going to get 1 over u times 2, which is 2 over 2t plus 1. Cool. So then the derivative here is 2 over 2t plus 1. This is your function for velocity. Nice. Your job is to find the initial velocity. That means when t equals 0. So we're looking for 3 plus 2 over 2 times 0 plus 1, which gets us 3 plus 2, which is 5, and this is going to be meters per second. Then they want the velocity at the top of the hill. So we know that the top of the hill from up here took us 65 seconds. So we're just going to plug that in. So we're going to say 3 plus 2 over 2 times 65 plus 1 is equal to 3 plus 2 over, that would be 120, 131, which is about 3.01 meters per second, which makes sense. Like, was going pretty fast at the beginning, kind of slowed down near the end. And our last job is to show that the cyclist was always decelerating. For that, we're going to need the second derivative. So x double prime is going to be, we're going to need the derivative of this guy. So I'm going to write that as x equals 3 plus 2, times 2t to the negative plus 1 to the negative 1. Okay. Derivative of this is just going to be 0. So what we're going to have to do is a chain rule. And so we're going to say y equals 2 times u to the negative 1. U is 2t plus 1. dy du is going to be negative 2, u to the negative 2. Du dt is going to be 2. So then we're going to end up multiplying those together. And we're going to get negative 2 times u, which is 2t plus 1 to the negative 2. Times 2, and so our final answer is going to be negative 4 over 2t plus 1 squared. And the way that we're showing this is this thing is always negative. There's no way to not make this negative. And because this is always negative, I'm always decelerating because I've got a negative, I'm moving forward, and I have a negative acceleration and a positive velocity because this thing is always positive. That means that I'm always decelerating. That's how y'all would go about it and describing that. Let me know what questions you got.